What if everything we thought we knew about the birth of our universe was just the surface of a much deeper, stranger truth? For over a century, the Big Bang has been our guiding story, a fiery beginning that marked the origin of time and space. But now, a new theory has emerged that challenges that foundation entirely. It's called quantum genesis, and it suggests that our universe didn't explode into existence. It emerged from something even more fundamental, a quantum realm where space, time, and matter don't just appear, they're generated. This theory might not only rewrite the first chapter of our cosmic history, it could change the entire book. In this video, we'll explore how this idea reshapes our understanding of space itself, why leading scientists are taking it seriously, how it connects to black holes and quantum entanglement, and what it means for the ultimate fate of the universe. 4. As long as we've looked up at the stars, we've searched for answers to the biggest questions. Where did everything come from? What came before the beginning? The Big Bang theory has offered a powerful explanation, but it also leaves us with unsettling gaps. What triggered it? What was there before time began? That's where quantum genesis steps in, a radical new concept born from the intersection of quantum physics and cosmology. It's not tied to a single star or galaxy, but instead to the very fabric of reality itself. The idea first gained traction when researchers studying the early universe noticed strange patterns in the cosmic microwave background, the leftover glow from the Big Bang. These fluctuations didn't quite match what traditional models predicted. Around the same time, developments in quantum gravity, especially theories like loop quantum cosmology, began to suggest something wild. Maybe the universe didn't start with a bang, but rather with a quantum bounce. And now, for the first time ever, simulations based on these models are offering testable predictions. They hint at a universe that may have existed before our own, or at least a phase of reality where time worked differently. Scientists are cautiously excited, calling it one of the most promising attempts to merge quantum mechanics with general relativity, a long-sought unification that could crack open the door to a cosmic revolution. Imagine the universe not as a one-time explosion, but as something that breathes, expanding, contracting, and expanding again in a kind of cosmic heartbeat. That's the core idea behind the theory of quantum genesis. Instead of the universe bursting into existence from a singular point of infinite density, what we've long called the Big Bang, this theory suggests that what we think of as the beginning was actually a rebound from a previous universe that collapsed in on itself. To grasp this, think of a trampoline. If you drop a bowling ball onto it, the fabric stretches downward and then it bounces back up. In traditional physics, as you push deeper, closer to that singularity, the math breaks down, predicting infinity. But in quantum physics, especially in loop quantum gravity, space-time itself is quantized. That means it's made of tiny, indivisible units like pixels on a screen. These quantum loops act like a safety net, preventing the fabric of space from collapsing to nothing. Instead, it bounces, triggering a new expansion, a new universe. Now, this isn't just a mathematical curiosity. Scientists are using real observational data to test these models. The Hubble Space Telescope, and more recently, the James Webb Space Telescope, are peering deeper into space than ever before, essentially looking back in time. If the universe had a bounce instead of a bang, there should be subtle fingerprints left behind in the oldest light, the cosmic microwave background. That's where missions like the Planck satellite have helped, detecting tiny temperature fluctuations that hint at something more complex than a simple explosion. Meanwhile, gravitational wave detectors like LIGO and Virgo are listening for ripples in space-time that may one day reveal echoes from this pre-Big Bang phase. Neutrino detectors buried deep in ice and rock are monitoring elusive particles that could carry secrets from those earliest quantum moments. This isn't science fiction. It's real, rigorous science that could soon reshape our understanding of everything. Because if quantum genesis holds up, then our universe wasn't the first, and it won't be the last. We may be part of an eternal cosmic cycle, and we're just beginning to catch the rhythm. Here's the mind-bending part. If this theory of quantum genesis is correct, then the event that created our universe didn't just happen 13.8 billion years ago. It might have been the final moment of a previous universe, collapsing inward, reborn through a bounce that sent everything flying outward once more. But because we're looking at all of this through the lens of time and space, which are themselves part of this expansion, we're essentially watching ancient history play out in real time. The light from the farthest galaxies we observe today left those galaxies over 13 billion years ago. So, when we peer into the deep field with the James Webb Space Telescope, we're not just seeing far, we're seeing back to a time when the universe was still young, chaotic, and glowing from its birth. If the bounce happened before this, then its signature may already be out there, hidden in plain sight, encoded in the cosmic microwave background or faint, gravitational ripples still echoing across the cosmos. And if we ever do detect an actual remnant of a cosmic bounce, an unmistakable fingerprint from before the Big Bang, it would be the ultimate spectacle. A moment that could light up the world of physics like a second sunrise. We wouldn't see a literal explosion in our skies, but the implications would shine just as bright, rewriting textbooks, reshaping theories, and forever changing how we view our place in the universe. Imagine stepping outside one evening, expecting a typical night sky, only to be met by a blinding brilliance where none should be. A new star has appeared, brighter than Venus, rivaling the full moon, visible even during the day. It doesn't flicker. It pulses, steady and radiant, as if the universe itself left a light on. This is no ordinary sight. It would be the visible signature of a quantum event, not just the collapse or birth of a star, but the potential evidence of a rebirth of reality itself. Across every continent, people would look up, cameras flashing, telescopes turning, and scientists scrambling to capture every wavelength. For days, even weeks, this light could dominate the skies, refusing to fade. Its glow would stretch across oceans and time zones, a beacon in the sky reminding us that the universe is still alive with mystery. We've had supernovae light up our night sky in recorded history. But if the quantum genesis theory is linked to a visible cosmic event, some ripple from before time that shines now, it wouldn't just be a once-in-a-lifetime event. It would be a once-in-civilization moment. The kind of moment when humanity collectively pauses, breathes, and stares in awe, not just at a light in the sky, but at the possibility that our understanding of everything has just shifted forever. The significance of witnessing an event tied to quantum genesis goes far beyond the spectacle. This is a goldmine for science, a live glimpse into the engines of creation. If this theory connects to a massive stellar event, we could be watching the birthplace of the very elements that make up everything around us. When massive stars reach the end of their lives and explode, they release unimaginable energy, forging heavy elements like gold, platinum, and uranium. These aren't just rare minerals. They're the atomic building blocks of planets, of life, of us. It's called cosmic recycling. The carbon in our cells, the calcium in our bones, the iron in our blood, all were born in stars like this. When they die, they give us the raw ingredients of existence. And with stars even more, massive than what we've seen before, like Antares or VY Canis Majoris, the possibilities multiply. These giants live fast, burn hot, and die young, but in their deaths they seed the universe with the potential for life. Quantum genesis, if proven, would layer in something even deeper. It might hint that the process of cosmic creation isn't just physical, but foundational. That beneath every supernova lies the fingerprints of a greater framework, a quantum code responsible for building universes. And as we begin to decode it, we're not just learning about space. We're learning about the origin of everything, including ourselves. Despite how dramatic and explosive this all sounds, there's no reason to worry. Earth is completely safe. Even if this quantum genesis event is tied to a powerful supernova, it's far enough away that the energy released wouldn't harm us. The explosion might be bright enough to light up our skies, but the radiation won't reach levels that pose any threat to life on our planet. In fact, the only effects we might notice down here are beautiful, harmless ones, like enhanced auroras or minor shifts in our upper atmosphere's ionization. Think of it as the universe putting on a stunning light show, not a danger warning, and thanks to our global scientific infrastructure, we'll have time to prepare for it in advance. Before any visible light even reaches Earth, sensitive neutrino detectors, deep underground, will pick up the first subtle signs of a star's core collapse. That gives astronomers a head start to alert the world, point their instruments to the sky, and prepare for what's coming. It's like having an early warning system built into the cosmos itself. We're witnessing the final breath of a giant, a farewell millions of years in the making. The light from this event has traveled across space for centuries, maybe longer, just to reach us now. It's a cosmic echo of something ancient, something powerful, something that reminds us how small we are, and yet how connected we are to the stars. In a way, we're not just observers, we're participants in the universe's grand story. Moments like this make you pause. They stretch your mind across time and space, forcing you to imagine the unimaginable. Stars dying to give life, galaxies colliding in silence, particles dancing through the void. These are not just distant curiosities. They are part of us. Every atom in your body was once forged in the heart of a dying star, scattered into space and recycled into something new. You're made of the universe. And the universe continues to evolve inside you. So the next time you step outside and look up, remember, the sky isn't just a backdrop. It's a living, changing record of everything that came before us. And everything that's still to come. Keep watching. The universe still has secrets to share, and we're only just beginning to listen. If you found this story fascinating, don't forget to like, subscribe, and share your thoughts in the comments below. Let's keep exploring the universe together, one mystery at a time.